Welcome to the Flexum Training Series. This is video 1A, hands-on training on how to program and install the Flexum F601 portable meter. Congratulations on your F601 portable flow meter purchase from Flexum. The F601 has been packaged in a very nice, robust Pelican carry case. It's been smartly laid out. You have your power cord, tape measure, your download software. Here's your data package, which has your manual and pipe charts and other important information, flow calibration on the meter. Top panel pulls out. It contains your meter, your transducers are coiled around here. It has enough size to fit at least 2 size transducers. I'm carrying here the M transducer and the Q transducer. With the M size transducer, you can cover from roughly 4-inch pipes to essentially the largest size pipe that you can still get a signal through, which depends somewhat on the pipe conditions, but you can easily do a 40-inch pipe, a chill water type application, or most liquid applications that are not introducing an extra level of challenge like a slurry or old pipes that may have a lot of scaling buildup. With your Q-size transducer, you can cover from 1/2 inch to 4-inch pipes, and that can be stretched up to slightly larger diameters, 6, 8, 10-inch, depending on the condition, again, of the pipe. Here we have some pretty good pipe, stainless pipe. The Q-size transducers would work quite well if this were a 12-inch. It happens to be a 6-inch. The Q-sizes would work well on this because you'd still get a strong signal. In the bottom part of the panel, it contains all the mounting hardware, chains for mounting the portable transducers, coupling grease, temperature sensor if you have the temperature accessory, and you're going to be doing either just standalone temperature measurement and maybe BTU measurements. Okay, so we're just going to get right into it. We'll take the Flexum portable meter out of here. It's been very smartly designed for handling. It has a retractable arm that you can set it up on a table. You can set it on the pipe sometimes like this. It also comes with a pipe strap, and we can put the pipe strap on and snap it to the pipe strap. One of the things that we try to get people to recognize is that this is really quite an easy meter to program. I expect that within 5 or 10 minutes time on this video, we'll have the meter up and running, and you'll see how easy it is to operate your new F601 portable. Okay, so we start off, we'll hit the on key. We'll see the Flexum introductory screen come up. Gives the Flexum part number and serial number of the meter. Now we're in the base menu of the Flexum meter. There's 4 key parameters here. The first one on the left says PAR, that stands for parameter. MEA stands for measure. OPT for options. And SF for special functions. Now you see you have arrow keys, left, right. The number 4 key has a left arrow sign on it. The 6 key is right. The 8 key is an up arrow, and the 2 key is a down arrow. So I can move along the menu screen with the arrow keys. So if I go left here, you'll see that the arrows are now over the parameters part of the menu. That's where we'll start. Typically, the thing to remember is that the programming starts from the left and proceeds to the right. Okay, so we pressed our arrow key over, and now we see that the arrows are on the parameters part of the menu. And the thing to remember here, quite simple, is that we're going to do our programming from left to right. So we're going to start at parameters. Parameters is where we're going to enter in the pipe information about the pipe and liquid. And the measure screen is where we're going to go to take our measurement. Some of these other items here, options and special functions, are screens where we will be choosing additional items, such as if we want to decide that we prefer to read it liters instead of gallons. If we want to turn on our data logger, we want to set our clock. All these things are done in the options and special functions part of the menu. The main entries are done for simple flow measurements, are done in parameters and measure. Okay, so we're going to start off at parameters here. we're going to hit the enter key. And the first question it asks is channel A. Do we want to program the channel A? You'll see a little, if you can see this little arrow prompt here. Anytime you see that, that means if I press an up or down arrow, it will toggle me through other choices. And the other choices I'm looking at is A, channel B, channel Y, and channel Z. Now, this meter is a 2-channel meter. All of the F601 portals are 2-channel capable. Then we have a channel A and a channel B, which means we can run flow measurement tests on 2 different pipes simultaneously, one on channel A, one on channel B. We can do additional things like summing and subtracting, and that's where we would use the Y and Z channel. Those are calculation channels where we could say I want the Y channel to be the A channel minus the B channel. Okay, so we're going to choose channel A here, and one of the things we also want to do before we start the programming is we want to connect up our transducer, because the meter needs to recognize the transducer and know which transducer we're doing our measurement with. Now, we have to know a little bit something about which transducer to select. And again, there are 2 basic sizes of transducers. The M size, and you'll see it on the top of the transducer. This one says M2N7, and the M sizes are good from 4-inch up. You can stretch it down to even down to 2 inches. That's the main size range, is 4 inches and up. The Q size here, smaller size transducer, is good from 1/2 inch up to 4 inches, and that can be stretched out a little further from 4 inches. Okay, so you have to know which transducer, based on the pipe size you're measuring, which transducer you need to pull out of the suitcase. So now we're going to plug this transducer in so that the meter has a chance to recognize which transducer we're working with. There's a red dot on this LEMO connector here, and on the top of the connector you'll see a red dot as well. And we line up these 2 dots, plug it in, and I don't know if you were able to see that or not if the camera was zoomed in, but when we plugged it in, it said detected transducer on channel A. I'll do that again. Okay, and you see it says clamp on detected on channel A. So it has an automatic recognition of the transducer. Inside this LEMO connector here, there's a micro, what we call sense prompt chip, and that sense prompt chip contains all of the information about the transducer, as well as its calibration information and what size transducer it is. So it both installs the calibration data for that transducer and tells the meter what transducer you're using. So that's one of the things that you can't make a mistake on when you're programming the meter as well. So back to the parameters menu. We hit the enter key, parameter for channel A. And the first thing it asks now is what is the outer diameter of the pipe. Now you can see that we've already cheated on this one, because this is a 6-inch pipe, but I'm going to enter that pipe dimension in for you. We just punch in 6.625 and press enter. Then we punch in the pipe wall thickness. This happens to be a 0.260 pipe wall. Now if I could just talk a little bit about pipe dimensions. You'll find on the inside panel of the meter a pipe chart, and there will be pipe charts for steel pipes, stainless pipes, Hastelloy, ductile iron, copper, etc. Now, this is one place where the user can make a mistake, and so I want to spend just a little bit of time on this. Now, this is a 6-inch pipe, nominally. If you look at the nominal size for a 6-inch pipe, it says OD 6.625, and if this were a standard wall pipe or a Schedule 40 pipe, the wall thickness is 0.280. Now I just want to emphasize that, because one of the common mistakes that people make when they're programming the meter is they'll put in 6 inches as the OD. So make sure you're putting in the true outside diameter of the pipe. One thing you probably want to do is to just verify what that is. Take your tape measure wrap the tape measure around the pipe. You've got the circumference, divide it by 3.14, you'll get your outside diameter. And I've found through a lot of years of doing this that these pipe charts are pretty true. So if you measure 6.628 and the outside diameter says 6.625, I would tend to put in the outside diameter that's referenced on the pipe chart, because it's probably more accurate than the measurement that you just took with a tape measure. There's also pipe charts in here for copper pipe. You'll sometimes come across like a ductile iron pipe or cast pipe, and you're not sure if it's a carbon steel or cast. By measuring the outside diameter and finding out where it fits on the pipe chart, that'll help you determine, do I have a carbon steel pipe or do I have a cast iron pipe? Because cast iron has different nominal dimensions than carbon steel. Stainless happens to be the same nominal dimensions as carbon steel. Okay, so I've measured, I've installed the pipe outside diameter, I've installed the wall thickness, and the next question the meter asked me is, what's the pipe material? And here we've selected stainless. You'll see if I have the little arrow prompt here, up down arrow prompt, so if I scroll through you'll see that there's quite a list of virtually any pipe that you're going to come across, you'll find in our list. There's the stainless again. Okay, so we'll stop on the stainless and hit enter. Now, if the material or the entry that you're looking for is already present, you just hit the enter key. And that moves you to the next question. Lining, it's asking about an internal liner. Some pipes have internal liners. Common would be ductile iron pipes that have cement liners, internal cement liners. If you choose yes, it'll ask you what the material type is of the liner, and then it'll ask you to enter in the thickness of the liner. Again, if you look at the pipe chart, you'll find on the ductile iron, you'll find also typical liner thicknesses. Okay, we'll say no on the liner. The next thing is pipe roughness. Now, the meter installs a default value for pipe roughness. That's internal roughness, and you're best to not think too much about that and just leave the meter's value alone. Next question it asks is, what is your liquid medium? Here you'll see it's got water, and I'll just run real quick through a lot of the choices: hydrofluoric, caustic, glycol, certain glycol percents, which you'll see a lot in HVAC type applications. We have some mobile therms where you'll see in very high temperature applications where we tend to use our wave injector and go up to 700 degrees. And continue around, ethanol, methanol, until we find water again. Diesel, crude oil, juice, milk, beer, of course, because it's a German product, and other medium, and back to water. Okay, so now we got water. We're going to hit enter, and it asks you for the temperature of the water. I can feel the temperature of the pipe. Feels like it's about 70 degrees. That's generally good enough, because it's not doing a calculation based on volume is not temperature determinant. So if we were doing a mass, the meter would have to know what the temperature of the liquid is, but for volume it doesn't really need to know that. The reason why it's asking what the temperature is because it has some impact on the angle that the beam enters the liquid, and that has impact on what the optimal spacing will be. So, but just a rough estimate's good enough. Let's say I put in 70 degrees. Okay, and we're done with what we had to tell the meter about the application parameters. Now we go to the measurement screen. Press enter. Now we've got measurement channels A, B, Y, and Z. There, you'll see there's a little check mark next to the A channel, and the other channels are deactivated right now. If I wanted to activate another channel, I would scroll over to it, activate it with an up-down arrow, deactivate it again, back to the A channel, hit enter. It asks a measurement point number. Now, it'll only ask this question if we have our internal data logger turned on. So it happens to be that this data logger is turned on right now. and this measurement point number is just an identifier for what the data set is now that we're measuring. And we can choose to put in a number, or we can choose to put in an alphanumeric name or number. Okay, I'll just leave the dash in there. I'll hit enter now. Now it's asking number of sound paths. Now typically, we recommend starting with 2 sound paths. Now 2 sound paths is when our transducers are on the same side of the pipe. One sends a sound beam out, it echoes off the far pipe wall and comes back to the receiver, and it's taking 2 round trips through the pipe, and that's why it's called 2 sound paths. One sound path would be where the other transducer is on the opposite side of the pipe. Let me show it to you like this so you can see it. That would be one sound path. We typically don't want to mount on the top and bottom of the pipe, because if there's any air in the pipe, it tends to cling to the top of the pipe, right? So it would be something like this. Now we recommend starting at 2 sound paths. It makes mounting the transducers and spacing and measuring the spacing distance much easier. And B, going through the liquid twice provides better averaging of the flow profile, so you can get potentially better accuracy than 1 sound path. The only time we traditionally would recommend 1 sound path is when you install it with 2 sound paths, and now you're looking for your signal, and you'll say you're struggling to get a strong signal. Then you come and change it to 1 sound path, and you would change the configuration. So we're going to start it off 2 sound paths. Hit enter. Now it gives us a recommended spacing distance, and it's saying 3.19 inches reflect mount. That's the distance that we're going to set these transducers apart from one another. And so we'll start off, we'll mount one up on the pipe, and then we'll measure the other one out. Now 3.19 inches is not an easy distance to measure off the tape measure. What we recommend you do, and it's quite acceptable, is to average that off to plus or minus a quarter inch. So if the 3.19, I'm going to average off to 3.25. Now, we won't cheat the meter. The last question the meter will ask us after we've completed the install is, what did we actually space the transducers at? So we have some flexibility, easily a quarter inch, but on larger diameter pipes we can get a little bit more flexibility on the spacing there. And sometimes we can even use that flexibility to fine-tune the signal to peak it out. And then ultimately the meter will ask us, what spacing do we have it set at, and we tell it. Main thing is that we tell the meter what we spaced it at. We don't deviate too much from what it recommended, and then we tell it what we have it at. We can't have it at a spacing at 6 inches and tell it it's at 3 inches, because now we've lied to the meter and an error is going to result from that. Okay, so we've got a couple of different means of mounting up the transducers. I'm going to start off with the most basic. This is our basic mounting kit. We have other types of mounting apparatuses that are additional. Now, this is a chain type. You'll get this bracket here that slides into the top groove of the transducer. So we slide that in. Take out our coupling grease. Put a little bit of grease right down the center of the transducer. Don't have to overdo it. Now there's an arrow. If we hold these two transducers up, we'll see that we can make an arrow with that. Now that kind of makes it foolproof. What we want to do is face the arrow in the direction of flow. Now on this pipe, the flow is going this way. So we're going to face it that way. Okay, so we'll get the first one up there. Second one. Now, at this point, we can move to our signal screen. And we're going to get one of the nice features of this meter is that it gives us immediate feedback on the signal strength. You'll see that I can just hold this transducer to the pipe and approximately 3 inches, and you'll start to see the signal on the display. Want to zoom in on that? There you go. And you'll see that if I move the transducer around a little bit, you'll see I can see some varying amounts of signal. And probably where I'm seeing the highest signal is going to be where I wind up at the 3-inch point. And once I get the chain on, I'll measure it out with the tape measure. Okay, I'm going to show you this one more time. I'm just holding one transducer on the pipe, and you'll see as I slide it, I'm sliding it in closer. You see the signals dropping down. Now I'm sliding out, and you see the signals increasing, and this is closer to the 3-inch point. Now we don't want to do that when we install the meter necessarily slide the transducer back and forth. I'm just giving you a demonstration here. What we want to do is measure it out and put it at the recommended spacing. We would only engage in that type of optimization if we had a weak signal. So now I'll begin. I'm using my eyes right now to kind of sight what 3 inches are. Now I'll measure it out with the tape, and I did a pretty good job there. That's 3 1/8. And I said I was going to go for 3 1/4, but since I got such a nice 3 1/8 rounded off there, I'm going to leave it at 3 1/8, and I have to tell the meter I have it at 3 1/8 now. I like the signal. The amount of signal that we're looking for, you zooming in on that now? Okay, the amount of signal that we're looking for is about 3 bars of signal. As we get to about 2.5 bars of signal, we'll see that light is maybe starting to flicker red. And so we need to get above 2.5, 3 bars of signal to get a green light, and that means we've got a good signal. You've got to see a green light. If you don't see a green light, we don't have a good signal. Okay, so we got green light, lots of bars of signal. You'll find yourself sort of rooting for the signal now, because you know that when you put this thing on the pipe, if you've got the 3+ bars of signal and you have a green light, you're going to do good. And the difference between having, say, 3 or 4 bars of signal and having 6 or 7 bars of signal does not mean that I'm going to have a more accurate reading because I have 7 bars of signal. You just have to be above the minimum level. Okay, so I like what I see. I'm going to hit the enter key now, move on to the next cell. The last thing now that the meter is asking me is what distance did I space the transducers at. I put it at 3 1/8. That's 3.125. I enter in 3.125. Now don't forget to do that, because the value that was in there was the value that was there from the last time you used the meter. And if you leave that alone, it's gonna do a calculation based on an incorrect distance that it thinks the transducer is at. So don't forget this step. Now you tell the meter what distance you have the transducer spaced at. You press enter, and you're ready to start measuring flow. And we'll turn the flow on in this loop in a second here. But just as a review, I'm going to go through this again for you. I'm going to show you kind of how easy getting this meter running is. Okay? So we're going to start this off one more time here for you. Let's hit the brake key. Now we hit the brake key anytime we want to go back to the main menu screen. Anytime we want to go backwards, if we're going forward through the menu and we go one beyond where we want to be, there's no real back arrow when we're programming this meter up. So we've got to hit the brake key and then get back to the main menu screen. Okay, so now I'm going to hit the brake key. Now if you'll just focus the camera on the meter here, I'm going to start at parameters. I'm going to hit the enter key. Parameters for channel A, enter. I'm going to enter in my pipe size. It already has that value. If I want to, I can just hit the enter key, but just for demonstration, 6.625. I'm going to enter in the wall thickness, 0.260. The material, hit enter. No liner, enter. Roughness, leave it alone, enter. The liquid's water, hit enter. Temperature 70 degrees, hit enter. I'm done with the parameter entries. Go over to measure, hit enter. I got a little check mark next to the A channel. That's the one we're working with. This is A channel. The plug-in for the B channel is over here on the meter. Hit enter. That's a tag number for the data logger. We don't have to put anything there if we don't want to. Number of sound paths, I'm going to change that to 2. Now you'll see that it defaulted itself back to 1. That's because I went over to the parameters menu and it created this, it caused this to go back into a default state. Okay, so I'm going to hit the 2 sound paths, enter. And it gives me the spacing distance, 3.19 inches, enter. My signal strength, lots of bars of signal, enter. My actual distance I put the meter at, 3.125, enter. And I'm reading flow. Now before I show you the flow, I just want to show you one more thing. Now this diagnostic screen, the diagnostic that we call sound speed or sound velocity, the sound speed of the liquid. Now one of the things we put in with the portable meter along with the pipe tables is you'll see a chart here for sound speed. Can you get a look at that? Can you see that? Now you'll see, let's say I have a temperature 70 degrees. I don't know if you can see that, but it's saying that the sound speed of the liquid should be 1485.7 for 70 degrees. Now this is sound speed of pure water. This is not pure water that we have in this lab. It's got some minerals in it, so we're going to expect this we're going to allow for some variation. But this is what we call our checkpoint. Now we know what the sound speed of water should be. We know what it should be at 70 degrees, and we're going to look to see that that's the sound speed we get. If we don't, then it means that we did something wrong. Now I'm showing you how to get to the sound speed. If you want to zero in on the meter here again. Okay. Now when you're in the flow screen, over here the number 3 key up here along the 3 key it says display, and along the 9 key here it says display. Now the 3 key will show you information on the bottom display, and the 9 key will show you information on the top display. So I'm going to hit the 3 key, and the first thing it tells me is flow velocity, so I can see what my velocity is in velocity terms. In this case here, feet per second, but if I wanted to see it in meters per second, I could change that unit. And now sound velocity of the liquid. And you'll see that we're getting a sound velocity of 1491. The table said that I should have, for 70 degrees, 1485. So that's pretty close. And I didn't actually measure this water temperature, but that tells me that I've installed the meter properly. And that's the biggest hurdle that you have to get over. When you install the meter, there's two main diagnostics that you're going to look to that tell you that I've done it right. And if you do it right and you're getting that proper diagnostic feedback, you can trust the readings. You're going to have pretty accurate readings. The meters are all wet flow calibrated to 1%. And giving your piping conditions, if you have a fair straight amount of pipe, you're going to be in that 1% range. So sound speed is important as a good diagnostic check, and signal strength as well, but sound speed really tells you that you've done everything right. If, for example, I would have programmed the pipe dimension wrong, I would have seen an error in the sound speed. Now, we're talking about the sound speed of water here. If you have a different liquid, we have quite an abundance of information on sound speeds. We can provide you with some additional information. You could call us, and we could also discuss it, and so that we could always give you an idea, more or less, based on the type of application you have, the liquid that you're flowing, more or less what your sound speed should be. Also, as you're learning, as you're using the meter, you'll learn about the sound speed of your liquid. So you put it on one pipe, you see what the sound speed is, then as you use the meter around the plant, you'll see that sound speed is consistent for that type of liquid. Okay, so if I hit the 3 key again, I get back to the flow screen. So it just toggled that bottom line. It went from gallons per minute to flow velocity to sound speed. Okay, now we'll, here, this button here, the 8 key, is Q on. That's our total. So if I press that, it turns on the totalizer on the top line. So now we're going to turn on the flow a little bit here for you. We'll show you that the meter actually measures flow. Okay, I'm going to start up the flow now. This is the Flexum calibration lab that we're working in, and I'm going to dial in a flow of 300 gallons per minute. Now, the response that you see is settable. The meter has a default. Not sure what this meter is set at right now. Looked like it had about a 10-second response set in. You'll see that the flow is starting to settle into the setting that I set the CalLab for, which is 300 GPM. Okay, the master meter right now in the CalLab is showing 299.5, 300, 299.7. Pretty good, huh? Makes me look good. Okay, now you've seen how easy it is to install a meter. I'll just walk you through another section of the menu, give you an idea what some of the features and choices are that you have here. Let's hit the brake key. We'll go over to options. I see the arrows go over to options. We'll hit enter. Options for channel A, enter. Now we can choose volume flow, flow velocity, mass flow, thermal energy, sound velocity. Okay, back to volume flow, enter. We can choose the units that we want to measure in, gallons per minute, gallons per day, cubic feet per hour, and so on, metric units, liters, barrels, and back to gallons per minute. We can choose to have temperature measurement. Now this is a temperature sensor here that we have, just pulled out of our case, and this is a surface mount type temperature sensor that we have that goes with our portable meter. I'll mount this up real quick. Over she goes. Pull on this. It's spring loaded. It's on the pipe. Plug this into the bulkhead where the temperature measurement goes. Now if I choose yes, I'll have a temperature measurement for T2. Now I believe I'm plugged into T1, so I have to move this over to the T2 slot. Dampening setting, that's the response time of the meter. 10 seconds means it takes 10 seconds to ramp up to the flow rate. The trade-off there is response time versus stability. So if I choose a larger number, the response time will be slow, but the meter will be more stable. Store measured data, yes. This is where we turn on our data logger. Serial output, yes or no. Yes means that it's going out in real time. The serial port is up here on the bulkhead, and yes means that it's going out. The only time you would choose yes is if you have a laptop and you're collecting data directly to the laptop. Otherwise, you choose no, and the data is going into the meter storage. Storage rate, here we can choose what rate, interval rate we want to store data at. Every 10 minutes, every minute, every 10 seconds. We could choose extra, in which case we could define the number of seconds we want to store data at. Let's say I choose 10 seconds. Now, if I choose a data rate, storage rate of about 10 minutes, the meter will store from 4 to 6 weeks worth of data. It depends on how many channels we're operating. If we're operating 2 channels, it essentially will cut the time down in half. Current loop, yes or no. On the bulkhead, we have 2 current options, and we can output current for flow. Let's say, for example, if we turned it on, it would ask us what we want to set the maximum to and the minimum to. So well, that's pretty much it as far as the options in the meter. We hit the brake key. Our special functions over here contain things like setting up the clock time, the storage, deleting the data that's been stored, parameter storage. We can save up to 14 different sites, pipe sites, and we manage that in the special functions. But for the most part, the parts of the menu that you need to use with the meter are really quite simple. You go into parameters, you tell it your information, your pipe information, liquid, and then you go to measure. It tells you what space, distance to put the transducers. You install them, and you got your reading. So I hope that that this tape here gets you going. I hope that you get the most out of your F601 portable meter. I know that you will. It's the most robust portable meter that's on the market today. Very high quality, armored cable, 14 hours battery on the portable meter. You will really like this meter when you start using it. I happen to be very attached to mine, and I don't let it out of my sight. When my colleagues come and try to borrow it, I tell them to go fly a kite. Anyway, thank you very much. I appreciate you taking the time, and if you have any more questions and you're out there and you're using this thing, give us a call. Look us up, our numbers on the field manual, and call us, and we'll help you. Thanks.